Okay, so yesterday we talked about box and whisker plots. So yesterday we talked about box and whisker plots. And remember, the box and whisker plot is going to divide the data into quarters. It's going to divide the data into quarters. So if you look up above, that's the first quarter, the first 25% of the data. There's the second 25% of the data. There's the third 25% of the data. And there's the fourth 25% of the data. Things are in quarters. With that comes the term quartile. So the end of the first quarter of data is called Q1, or the first quartile. The end of the second quarter is called Q2, or the second quartile. And remember, Q2 is the median. The end of the third quarter is Q3, or the third quartile. Lowest piece of data is the lower extreme. Highest piece of data is the upper extreme. What do we call an anomaly? What do we call something out of the norm that's unusual? Kaylin? An outlier. So outliers have asterisks. They don't really fit within the rest of the data. There is a mathematical formula to figure out if something is an outlier. And so there's a mathematical formula for that. All right, we went through then and talked about quartile. We looked at all the values and such. Be careful here. Students tend to forget about the interquartile range. That's the range of the box and whisker plot. So really Q3 minus Q1, that will give you the range of the box, or the interquartile range. We then went on to make two box and whisker plots. The first example is making a box and whisker plot with an even amount of data. To do that with an even amount of data, you have to find the median of the two middle pieces, right? Anytime you have an even amount of data, the median is the average of the two middle pieces. You will then break up the left side and right side of what's left, find the median of the lower side for Q1, the median of the higher side for Q3. Now you have your box. Lowest value is the lower extreme, end of the one whisker. Highest value is the upper extreme, end of the other whisker, and there is your box and whisker plot. Now I did say I was a little uneasy with using that middle piece of data and not including it in the left and right sides, but that is the way it's done, though I don't like it. It's just really mathematically, there's something a little bit off there, but such is the way it is done. So when you have an odd amount of data, the middle one is going to be the median. Then you still have lower halves, what's left on the left, upper half, what's left on the right. Find the median of the lower for the Q1, the median of the higher for Q3. You're able now to make your box. Again, highest and lowest for the whiskers, and away you go. Now, it depends on how many pieces of data with the odd amount of data. If we had 11 pieces of data, the middle one would leave us 10. There'd be 5 on the bottom and 5 on the top. So the 5 on the bottom would have a middle piece of data, right? You wouldn't have to average. Just depends on what you got. But again, you're always going to use that middle piece of data. Then go ahead and figure out the median of what's left on the left, the lower end, and the median of what's left on the right. And voila, you got your box and whisker plot. Now, I tried to help you guys out. I, on your worksheet, have provided you with number lines already, so you don't have to come up with your own number line. Normally, to make a box and whisker plot, you'd have to make your number line and make the box and the whiskers. I provided the number line for you, but just make sure things go in the right place. Any questions about box and whisker plots? Anybody? Nick? Yes. The Q's are all the medians, Nick. So the Q2 is the median of all the data, middle piece of data. Q1 is the median of the data left on the low side from the median, and Q3 is the median of the data left on the high side of the median. So I'm assuming you did not have a chance to watch the video last night. Okay. So go back and watch the video and you'll get all that stuff there spelled out for you. Ileana. You'll have to figure that out, won't you? You're a smart girl. Okay. Use your brain. Math is orderly, is it not? Okay. So do what you think might fit Q sub 4. All right. Math is orderly. We can draw conclusions from math. And by the way, the difference between being just so-so in math and being excellent in math is being able to take principles of what you learned and apply it in a little bit different variation, or maybe something you haven't been directly told, but you take those principles and you apply it. Okay. Now, if you don't know what to do, it's always worth a guess, and make an educated guess on what you think the answer would be. And on that one, I'm pretty sure you're going to end up in the right place. Okay, so today, 10.2b, we've already done the box and whisker plot. Now we have a stem and leaf plot. Some call them a stem and leaf diagram, stem and leaf graph, all kinds of different names. A stem and leaf plot is used to display the data within its, intervals. Within its intervals. All right, what's an interval? What is an interval? Come on, just talk about normal life. What would an interval be? Jordan? Okay, not bad. Interval. John? Okay, and is an interval like one number? How long is a normal interval for halftime of a basketball game? Do you guys know? 10 minutes, right? 10 minutes is a normal halftime of a high school game. NBA is different, NFL is different and such, but intervals. So a lot of times in data, we are concerned about the intervals. For example, a normal grading scale, let's just say this way, a popular high school grading scale is this. 60 to 69 is a D. 70 to 79 is a C. 80 to 89 is a B. And 90 to 100 is an A. That's a pretty standard grading scale. Probably the most common in the States is that grading scale. Well, an A is an interval of 90 to 100. A B is an interval of 80 to 89. A C is an interval of a 70 to a 79. A D is an interval of a 60 to a 69, and then anything below 60 is no good. Subpolar, and you don't want to be there. Right? Those are intervals. And so that's a stem and leaf plot is used in something where the intervals matter, and we want to know about the intervals. Okay, so I've got an example here of a stem and leaf plot. There are a couple things that this one has that all of them do not have. So number 2 has everything listed. Not all of them do. This one has a title. It's nice to have a title. It tells you exactly what this thing's about. California temperatures. We can all comprehend that. So because this stem and leaf plot has a title, we understand what it's about. You don't need to circle this, but the word stem and the word leaf are listed. Not every stem and leaf plot lists the words stem and leaf. This one does. Not everyone will. And the ones that don't, they will expect you to know that the numbers on the left are the stems and the numbers on the right are the leaves. Sounds like a good quiz or test question. Which ones are the stems and which ones are the leaves, right? So the stems are on the left, the leaves are on the right. So those words will not always be there. The other thing this one has that not all have is a legend. What's a legend? Don't talk about my football career. But what else would be a legend? What's a legend in this context? Okay. Again, not my football career, but this stuff. What's a legend? Jack? It is directions. A lot of maps have legends, graph have legends. Is something that tells you about whatever you have a picture of. This is a stem and leaf plot. We have a legend, and a legend tells us how to read the stem and leaf plot. So the 7, and then you have this vertical line. See this vertical line right there? You don't need to write this in your notes. I'm just getting you think you can if you want. Is this vertical line right there? So it says if you have a 7 on the left and then that vertical line and a 2 on the right, it's the number 72. Do you see that? So here's what we've got according to the legend. We have in this first top row a 72, a 75, a 77, and a 79. Now you can write them if you want. That's what you have. The legend tells us that, right? A 72, a 75, a 77, and a 79. We know that the second row down contains an 82, an 83, and an 86. And you can go on and finish. The fourth is a 92, 93, 95, 98, 98. And what's the last piece of data, Devin? 102. 102. Okay? Which interval has the most pieces of data? Somebody raise your hand and tell me. Which interval has the most pieces of data? John? Okay, and what is really the 9? Give it more in an interval, John. Can you give 9 as an interval? Yeah, it's the 90s, isn't it? Right? Isn't the 9 representative of the 90s? 92, 93, 95, 98, 98, right? It's the 90s interval. Okay. This is the value of a stem and leaf plot. At a quick glance, you can tell which interval has the most data. That's its value. Everything has its own value. We're going to talk about pie charts tomorrow, bar graphs, broken line graphs. We've already talked about a box and whisker plot. They all have their value. Some of your dads or moms that give presentations, maybe at the Pentagon, maybe where they work, if they give any kind of presentations, often they'll put some charts in their presentation. And if they know what they're doing, if it calls for a pie chart, they'll use a pie chart because the data says, hey, with this kind of stuff, what I want to illustrate, pie chart's the way to go. But if they ever want to illustrate something with intervals to make clear where the most data is in a certain interval, they'll use a stem and leaf plot. Different kinds of applications to display different kinds of things. So that's the idea. So the 90s interval has the most data. Please note that the leaves are lined up in vertical columns. Again, don't do this in your notes. But notice how all those 2s are nice and lined up in a vertical column. The next column has a 533. The next column a 765. The next column an 8, a 98, and the last column the 8. This is what I've seen students do with their stem and leaf plots. Don't write this. This is what I've seen. I can't have an 11. Do another 9. Is it clear now where the intervals are and how much data is in each interval? Is that clear anymore? It is not, because nothing is in nice and straight columns. And you do not want to make a stem and leaf plot that way. You want to be able to clearly at a glance tell the intervals that have the most data. And we can easily see the 90s has the most, the 70s has the second most, 80s has the third most, and the 100s has the least. Very clear from a quick glance. That's the idea, and that's the value of a stem and leaf plot. It is about the intervals. Okay? So let's go ahead and do a few more things here. So the leaves are nothing more than the last digits. Leaves are the last digit of the data. And as I just mentioned, make sure the leaves line up in vertical columns. It's good to do a stem and leaf plot on graph paper. That'll help you to get everything in a nice vertical column. Nick, where have you been for the last 20 minutes, man? Oh, here you go, Nick. All right, so carrying on here. All right, so that's the leaves, right? The leaves are the last digit, and they should line up in nice columns. The stems are all the data digits except the last digit. Notice in our example, the bottom stem is a 10. It has 2 digits. Because again, the leaves can only be the last digit. If you had a number in the thousands, then the stem will have 3 digits, right? Etc., 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 etc. All right, so from this, we can conclude some data. We need to find the mean. All right, break your calculators out. Now, I've already listed the data. You may want to do this. John, can you get our door? Oh, sorry, John. Okay, go grab it. Hey, class, while you're grabbing for your calculators, I've already listed the data off to the side. You know what a mistake students do when they find the mean? Everybody look up here. Look at the screen. Just watch, pause for a second. You'll find the mean in a minute. This is what students do that make a mistake. They'll add 2 plus 5 plus 7 plus 9. Is that what those numbers are? No, that's a 72, a 75, a 77, and a 79. Don't make that mistake. All right, go ahead and figure up the mean. So notice I left a place to put the total top number, divide it by the total number of pieces of data, and then give the final average in the next blank. Go ahead and figure out the mean. Ah, the bottom amount of numbers is the same as tomorrow's date, which is a Friday. Oh. You know, my oldest daughter was born on Friday the 13th in Munster, Indiana. Ooh, scary. I was in the father waiting room and someone asked, do you want your kid to be born on Friday the 13th? And it was like 9 o'clock in the morning. And I said, I don't want to wait until the 14th. Actually, my wife would not have wanted to wait until the 14th. Everybody got a mean? You got a mean? You got a mean? Punching buttons? Oh, let me do this. Please stand if you don't have a calculator with you today. Anybody? Everybody's got a calculator? Just Mr. Turner. Uh-oh, you're immortalized on video now, Mr. Turner. Anybody else without a calculator? All right. All right, on 3, give me your mean. Oh, by the way, Nick, how would we, what kind of form would we leave our final answer in? How do we always, Nick, always leave our final answer and things like that? Very good. All right, so on 3, give me your answer. 1, 2, 3. Sounded like mush mouth. I hear a lot of non-confident people. Folks, we've already done averages. Kirsten, what was your top number? What was your top number, Kirsten? How much? 303? You can get 300 almost from those first 4 numbers. You got to find the mean of all the data. That's right. Mean is the mean of all the data. Anybody have a number on the top that's more than 1,000? Okay. Wyatt, what do you got? No, I asked you what your top number was of the fraction. Gabe, what do you got? Yay! That's what I got. I don't know why you didn't. All right. Look, quite honestly, if you can't punch numbers in a calculator, I can't help you. Okay. This course is not designed to help you to punch the numbers into a calculator. Everybody should have gotten 1,132. 72 plus 75 plus 77 plus 79 plus 82 plus 83 plus 86 plus 92 plus 93 plus 95 plus 98 plus 98 plus 102 is 1,132 divided by 13 pieces of data. And the answer is, Andrew, point what comes after the 0. So how are we going to round this thing off? 87.1, right? 87.1 is the mean. Don't make that hard. All right. Somebody raise your hand and tell me the mode. What is the mode? Mr. Shockey, give me the mode. Anybody agree? Raise your hand if you think the mode is 98. It would be all the correct ones. There are 2 98s. Everything else has only one piece of data. By the way, notice all the 2's in the stems, but they're all different numbers, aren't they? The one's a 72, the next is an 82, the next is a 92, and the next is 102. So that's not the mode. Or did you think it was? Right? It's not, because you got to remember what it is. It's the actual data. All right. 13 pieces of data. What piece of data would be in the middle? What number? Kaylin, sorry. Huh? Okay. Yeah, you might be ahead of the game here. What if there are 13 pieces of data, which number is in the middle? The first piece of data, the second piece of data, the third piece of data. There's 13 of them. Which one's in the middle? Connor? The 7th one. So either go from highest to lowest to the 7th, 1, 2, 3, 4, 5, 6, 7, or from lowest highest to the 7th, 1, 2, 3, 4, 5, 6, 7. And you can see Kaylin is correct, 86. And the last thing, what is the range? What is the range? Adam? Adam said 102 for my high and 72 for my low is surely a 30, and that is correct. Okay? So we can find all those things from our stem and leaf plots. Okay, here's another one. Notice the word stem is not there. The word leaf is not there. And notice that there is no legend. So you have to assume normal stuff. You'll have to assume that that first number is a 78 and the second is a 79, etc. Okay. Somebody raise your hand. What have you got for a mode? Nick? Nick says the most often occurring piece of data is 96. How many agree? Let me see your hands. You would all be correct. There are 3 96s. By the way, notice how clear the mode is in a stem and leaf plot. So the intervals are clear and the modes are pretty clear in a stem and leaf plot. All right, median. Find the median. 14 pieces of data. Alexandra, what do you got for a median? How many agree with Alexandra? 93. Uh-oh, only a few. Although the majority's not always right. Ashton, what do you got for a median? How many agree with Ashton? 94. Oh, we're still slight there. Antonio, what do you got for a median? How many agree with Antonio? 96.7. Ooh, Madison, what do you got for a median? LC, what do you got for a median? How many agree with LC? 95.5. A few more there. Boy, we are really scattered on our median. LM, Lauren Mitchell, what do you got for a median? Still calculating? Calculate sounds like the GPS calculating. Eduardo, what do you got for a median? How many agree with Eduardo? Finally, we hit the median, 95. Look, I even had up there 94 plus 96 divided by 2. It's 14 pieces of data. Watch. 1, 2, 3, 4, 5, 6. There's the 7th and the 8th. 94 plus 96 divided by 2 is 95, people. Got to find the average of the two middle pieces of data. Jack. And you know that's wrong for the reason of I just showed you what the median was. And the range is what? Blake? Say it again. 51. So Blake did the high of 129 minus the low of 78, and 51 is correct. Jordan. Correct. There is no data in the 110s range. That interval had no data. There's nothing there. Do you see any leaves there? There's nothing there. There's nothing there. There are no 110s. There's no 110, no 111, no 112, and it's clear that there's nothing there. Again, the value of a stem and leaf plot. All right, let's make one. So we're going to make a stem and leaf plot. You should always put a title in. So I'm going to say NFL Combine. But that's not enough. I'm going to say 40-yard dash times. It's kind of wordy, but I don't know what else to say. 40-yard dash times. NFL Combine 40-yard dash times. Somebody tell me what to put in for the stems. Stems. Kyle? Okay. Is that it? Is that the only stem? Want to go anything more? Okay, and that's correct, right? We only have 4s and 5s. If there would have been 6s and no 5s, would we include the 5? We would. Because you're just going to count in order. Just like this previous one that Jordan said, hey, there's no 11s. But we did include it. There was no 110s. We did include it to clearly show that there was no data in that interval. So if you're making one and there's no data in an interval, include that number if it's in succession. Okay? We didn't start at 1 and go to 2, 3, 4, 5. We don't need to. But we do have the lowest and the highest and whatever else would be in between. Okay. I'm going to do my leaves in green. Somebody tell me how to do the leaves for the 4 row. The 4 row. I'm looking for somebody that hasn't participated yet today. So either get your hand up or I'm calling on you cold. Oh, everybody's hand up. Oh, Sam. Yeah, you haven't done anything yet, Sam. All right, Sam, give me a 4 interval. Like this. And then what else? Yeah? And then on like that? No. You tried. And you can only be right if you try. And sometimes you won't be right when you try, but that's okay. You tried. All right, need somebody else who has not participated yet today. Austin. Right, like that. Okay. I thought you said 0.2. I'm sorry. Just a 2, no point. Then a 3. Wait, before we go too far, because we don't want to write all this stuff in. How many think Austin's right? Yeah, and actually that is the case. No points. So we got a 4, another 4, a 5, a 5, a 5, and 2 7s. And then our 5s are just a 0, a 1, and a 3. And remember, we're lining up our columns, correct? We are lining up our columns. In this kind of a scenario, you always want a key, because the key really is going to help somebody to know, is their time 42 or is their time really 4.2? You definitely want a key. I meant that to be black. You can make it any color you want. So I'm just going to use the first one. You can use any piece of data you want. And I'm going to say this equals what? Somebody raise your hand and tell me what this equals. Jack? Be more specific. I like that. Be more specific yet. Eliana? Yeah, give the seconds there. And that's going to help them know now exactly what's going on. Without that legend, they would think it's 42 whatevers. Oh, all right, that person must be really slow. The legend here really helps tremendously. Okay, stem and leaf plots. You usually won't do them with decimals, but I want to include one in case you come across one. It's possible. Do the decimals get included in the leaves? No. We find that out in the legend. We find it out in the legend. Okay? Remember, the leaves always only have one digit. All the other digits are part of the stems. Any questions on stem and leaf before I go on to the last thing? Okay. All right, that leaves last thought here. We've got some plots here. Anybody know what these are called? No. Jordan? Nope. John? Nope. If you think of this one, you get a little bit better idea, because you would say the points are what? I heard it. Scattered. This is a scatter plot. These are scatter plots. Scatter plots. Scatter plots are real life scenarios. The data doesn't necessarily line up in a nice line. Now the first one, the ice cream, and you can see that we have temperature on the bottom. By the way, it's in Celsius, so I converted it to Fahrenheit for you, because Celsius doesn't mean much to us. 15 degrees, is that a 16? 16 degrees is 61 Fahrenheit, and 34 Celsius is 93 Fahrenheit. But it's trying to show you that the sales will increase as the temperature increases. When it's 61 degrees, not too many people are buying ice cream. But get it up to 93, and you get a whole lot more. Notice this data follows almost a line. And we can conclude some things from that line. We'll do that in Algebra 1 next year, okay? Because the data is very tightly packed together. And in Algebra 1, we'll explain some terms with that. We'll wait for Algebra 1 for that. I will tell you this, though. Notice as the temperature increases, what happens to the sales? Do they go up or down? They go up. So this is a positive. This is a positive effect. We're going to use the term slope in Algebra 1. This is a positive slope. Later on, Algebra 1, we're going to use the terms growth and decay, and this is a growth. Notice the second one, as time or as temperature increases, what happens to the sales? They decrease. So this is hamburgers. The hotter it gets, the more people are buying ice cream than hamburgers, I guess. Right? As time goes by, it goes down, so this is a negative slope. And the last one, I guess, is coffee. And it didn't seem to matter what the temperature was when you're buying coffee. It didn't really matter. It was just all over the place as to how many bought on any given temperature. It was random. Okay? There was no clear correlation between the temperature and the number of sales. And you get a really scattered plot. The first two you can make a lot of conclusions from. You can infer some things from it. You can draw some conclusions from it. First one, as temperature goes up, you're going to sell more ice cream. So if you want to be an ice cream seller, do you want to stay open year round or not? Maybe not. If you're an ice cream seller, do you want to have your store in the north or do you want to have it in the south? Okay. If you're a hamburger joint, maybe you want to go further north and you'll sell more hamburgers. Who knows? But that's the value of any plot. All right, I'm done for today. Don't forget you have worksheet 10A and 10B. I'm going to pass out 10B right now.